For 50 years, software development meant humans typing syntax line by line. Well, that era is officially ending. Autonomous AI software engineers are no longer just autocomplete assistants, they are full-stack agents that architect, code, test, and deploy production-ready applications from a single prompt. Welcome to this TechViews 10x Explainer, where we are breaking down this monumental paradigm shift. Let's dive right in. Think about this for a second. According to the CEO of GitHub, AI is estimated to take care of 80% of code writing, and soon. We are rapidly moving away from a world where developers spend hours chasing down missing semicolons. Instead, we're entering a reality where human developers direct the strategy and the AI entirely handles the execution. Now, the most fascinating part of this shift is the architectural contrast. We're moving away from simple single-agent autocomplete tools, the ones that just try to predict your next line of code. We are replacing them with robust, team-based multi-agent systems. These new systems actually replicate real human engineering structures, dividing the massive, complex task of software engineering into highly specialized roles. Let's actually peel back the layers and look at how these state-of-the-art, autonomous engineering teams are architected. Because this isn't just simple text generation. State-of-the-art SWE agent frameworks operate in autonomous sandboxes. The agent reads the entire code base, builds its own internal dependency graph, writes code, runs terminal commands, analyzes compiler errors, and fixes its own bugs, all before ever opening a pull request. Frameworks like Agent Forge utilize a multi-agent workflow where specialized AI roles coordinate through shared memory. Imagine a virtual team. You've got a planner mapping out the execution, a coder producing the patches, a tester synthesizing tests, a debugger iterating on failures, and a critic validating the final result. They hand off tasks to one another exactly like a human engineering department would. But how do they know the code actually works? The secret sauce here is execution-grounded verification. Every single code change has to survive a resource-constrained, sandboxed Docker execution before the agents can move forward. It's a completely closed-loop cycle. Without that grounded feedback, AI models just cannot reliably verify correctness. But by forcing the code into a sandbox, the debugger gets real execution feedback to iteratively repair its own failures. Taking this a step further, the Agent platform explicitly models software engineering as an organizational process. It assigns roles, gives agents isolated sandboxes for parallel experimentation, and forces them to use structured pull request communication. Because it mirrors how human developers work with local environments so closely, this system operates with zero human intervention. And incredibly, it successfully resolves over 72% of tasks on SWE-bench, which is the industry standard test for solving real-world GitHub issues. But hold on a second. As AI systems take over the keyboard, we have to confront a massive new vulnerability. If autonomous agents are writing all the code, how on earth are we securing the AI software development lifecycle? The DevSecOps tools we've used up until now were built for human-written code. They simply don't have the built-in logic to handle the sheer volume and speed of AI-driven code generation. And get this, paradoxically, recent data reveals that critical vulnerabilities can actually increase by 37.6% after just 5 iterations of AI code refinement. I mean, you'd assume an AI refining its own code would make it safer, right? Actually, because of a phenomenon called feedback loop degradation, the AI can silently introduce brand new vulnerabilities into seemingly secure code during its autonomous loops. To combat this nightmare, researchers have designed a 7-agent security framework that shifts left, embedding specialized AI agents into every single phase of development. You have an agent handling threat modeling right at the requirement stage, a security design agent, a secure code generation agent, all the way down to a runtime security and compliance agent. Instead of just reacting to security flaws post-deployment, this system proactively secures every single phase. The core innovation keeping this whole thing from derailing is an iterative security gate mechanism. It continuously scores confidence based on static analysis and LLM security checks. If that score ever drops below 0.7, it acts as a tripwire, immediately escalating the code to a human review queue. It also enforces a hard limit of just 5 iterative code refinements to prevent the AI from spinning out into a state of security decay. Okay, so if autonomous agents are writing and securing the code, what do we do? Well, the human developer's job must fundamentally evolve into what we call intent-driven development. We absolutely have to transition from heavy, upfront spec-first requirements to intent-driven workflows. See, when working with AI, trying to fully specify every little detail up front actually slows your momentum because what you learn during the build often changes the solution itself. Instead, humans must define the boundaries, the core business intent, and let the AI discover the specific solutions during the build. This new methodology rolls out in 3 rapid phases. First is intent capture, where you define the why and the scope boundaries without prescribing exact solutions. Second is the build and discover phase. Here, the AI builds while logging daily ship notes, basically a running log of decisions and scope adjustments. This means if a deviation happens, product teams can course correct within hours rather than wasting weeks on a misunderstood spec. Finally, document the delivery, where accurate documentation is generated only after the reality is shipped. The code itself becomes your source of truth. You no longer need a multi-million-dollar engineering team or years of coding experience to build profitable digital products. At techviews10x.com, we teach you how to use these exact autonomous AI agents and automation systems to launch digital businesses, streamline your operations, and build high-margin revenue streams online. Head over to techviews10x.com right now to get our step-by-step implementation blueprints. Check out techviews10x.com. Because the economic moat has shifted. Value is no longer created by typing code, it's created by knowing which problems to solve and how to orchestrate autonomous AI agents to execute your vision. But we do need to ground the hype in reality by looking at hard benchmark data to see where these agents truly excel and where they currently break down. When we look at isolated bug fixes on the SWE-bench leaderboard, state-of-the-art models like Claude 4 and GPT-5 variants are approaching an incredible 75% resolution rate. For discrete issue resolution, the capability of these agents is just undeniable. It is exactly why we are stepping so rapidly into this zero-developer app paradigm. But let's be real for a second. Real software engineering isn't just fixing isolated bugs. Up to 80% of our software engineering effort involves the long-horizon evolution of massive, tangled legacy code bases. We're talking about iterative modifications across interdependent modules in response to dynamic, high-level requirements. This complex reality is measured by a newer benchmark called SWE-EVO. And this is where reality hits hard. It brutally illustrates the limits of our current tech. When faced with real-world software evolution on SWE-EVO, the performance of even the very best models like GPT-5 plummets from 65% on the SWE-bench down to roughly a 21% resolution rate. There is a massive, tangible gap between an AI fixing a localized bug and an AI orchestrating a code-based scale evolution. Why is the gap so big? Well, in these long-horizon scenarios, agents suffer from severe failure modes. They experience silent goal drift, where their objective shifts over time without throwing a single error. They suffer from context compaction, essentially forgetting critical details as they go. The strongest models primarily struggle with instruction following when given nuanced, multi-step release notes, or they simply get stuck repeatedly reading files and just give up prematurely. So, looking at both the incredible paradigm-shifting power of these multi-agent pipelines and their very real current limitations in long-horizon evolution, where does that actually leave you as a tech professional or founder trying to build the future? Here's the bottom line. The economic moat of software engineering has officially shifted away from typing syntax and moved entirely toward orchestrating robust agent environments and mastering intent definition. The human advantage now lies in defining the organizational structure, establishing those iterative security gates, and providing the clear boundaries that keep these AI agents aligned on the actual business goals. Software is becoming pure intent. As development rapidly becomes an exercise in intent rather than syntax, you have to ask yourself, are you ready to stop typing and start orchestrating the future? If you want to lead this transition, visit techviews10x.com to access our full training library. And make sure to like and subscribe to TechViews 10x.